Hey there and welcome. You might know us from Zentara.blog, where our team works hard to bring you 6 brand new articles every single day, breaking down big ideas into something you can easily get your head around. And now you're listening to Zentara Unlocked. Think of it as Zentara.blog for your ears. We'd love for you to check out the full articles with all the extras on Zentara.blog whenever you can. But if you're commuting, doing chores, or just fancy listening, we've got you covered with our daily audio editions right here. So, ready to learn something new today? Have you ever thought about what you have in common with a towering tree, a buzzing bee, a sparkling diamond, and even the air you breathe? The answer is a super special element called carbon. Carbon is like the ultimate Lego brick of life. It's in almost everything. But these carbon bricks don't just stay in one place. They are constantly on the move, traveling through our planet in an amazing journey called the carbon cycle, explained here for you. Understanding how the carbon cycle works for kids is like getting a backstage pass to see how Earth keeps itself balanced. We'll explore what is carbon and its role in Earth systems, and follow its path as carbon moving through atmosphere, ocean, land, and all living things. Get ready for an amazing adventure following Earth's ultimate recycler. 1. Carbon, the building block of life. So, what is carbon and its role in Earth systems? Carbon is an element, like oxygen or gold, and it's incredibly important because all living things on Earth are carbon-based. That includes you, your dog, the trees outside, and even tiny bacteria. Think of carbon atoms as tiny, super sociable Lego bricks that can connect with other bricks in millions of different ways to build all the complex molecules that make up life, like proteins, fats, and sugars, carbohydrates. Carbon isn't just in living things, it's also found in the atmosphere as carbon dioxide, or CO2, dissolved in the oceans and stored in rocks, soil, and fossil fuels like coal and oil. The carbon cycle explained is the story of how these essential carbon bricks move between these different storage places, called carbon reservoirs, ensuring that life always has the building blocks it needs. 2. Plants are carbon munchers, the magic of photosynthesis. One of the most important parts of the carbon cycle explained starts with plants, from the tiniest blade of grass to the giant redwood trees. Plants are like nature's chefs. Through a process called photosynthesis, they take carbon dioxide, CO2, from the air. Using sunlight for energy and water from the soil, they magically transform that CO2 and water into sugary food glucose for themselves and oxygen, which they release back into the air for us to breathe. That sugar is full of carbon, which the plant uses to grow bigger and stronger, building its leaves, stems, and roots. This is a huge step in carbon moving through atmosphere, ocean, land. Well, from atmosphere to land and living things. The photosynthesis, respiration, decomposition carbon cycle is a continuous loop, and photosynthesis is the crucial starting point for capturing atmospheric carbon. 3. Animals, including us, join the cycle, respiration, and eating. Now, how do animals get their carbon? We can't do photosynthesis. Instead, animals, including humans, get their carbon by eating plants, or by eating other animals that have eaten plants. When you munch on an apple or a salad, you're taking in carbon that the plant stored. When a lion eats a zebra, it's getting carbon that the zebra got from eating grass. And what do we do with that carbon? We use it for energy and to build our own bodies. Then, through a process called respiration, which is basically breathing in oxygen and breathing out carbon dioxide, we release some of that carbon back into the atmosphere as CO2. So, every time you exhale, you're playing your part in how the carbon cycle works for kids to understand. You're returning carbon to the air. This is the respiration part of the photosynthesis, respiration, decomposition carbon cycle. 4. The Great Decay. Decomposers are nature's recyclers. What happens when plants and animals die? Does all that carbon just stay locked up in them forever? Nope. This is where the decomposers come in. Nature's amazing recycling crew. Decomposers are organisms like bacteria and fungi. They break down dead plants, animals, and waste products. As they munch away, they release the carbon that was stored in those dead things back into the soil and, importantly, back into the atmosphere as carbon dioxide through their own respiration. This decomposition is a vital step in the carbon cycle explained, ensuring that carbon atoms aren't permanently stuck. It keeps the carbon moving through atmosphere, ocean, land, and living systems, making those carbon Lego bricks available for new plants to use, starting the cycle all over again. It's the decomposition in the photosynthesis respiration decomposition carbon cycle. 5. Oceans. The world's biggest carbon sink. The oceans play a huge role in the carbon cycle explained. They are like a giant sponge for carbon dioxide, holding about 50 times more carbon than the atmosphere. CO2 from the atmosphere can dissolve directly into seawater. Tiny marine organisms called phytoplankton, microscopic plants, float near the surface and, just like land plants, use photosynthesis to take up dissolved CO2 and convert it into their bodies. When these phytoplankton are eaten by other marine creatures, the carbon moves up the ocean food web. When marine plants and animals die, some of their carbon can sink to the deep ocean floor, where it can be stored for hundreds or even thousands of years in sediments. This process of carbon moving through atmosphere, ocean, land, especially into the ocean, is crucial for regulating Earth's climate. Understanding these carbon reservoirs like the ocean is key. 6. Rocks and really long-term storage, carbon locked away. Not all carbon stays in the fast loop of plants, animals, and the atmosphere. Some carbon gets locked away for incredibly long periods, millions of years. When marine organisms with shells or skeletons made of calcium carbonate, which contains carbon dye, their remains sink to the ocean floor. Over millions of years, these layers of shells and sediments get compressed and turn into rocks like limestone. This is a very slow part of the carbon cycle explained, but it forms one of the largest carbon reservoirs on Earth. Volcanic eruptions can release some of this stored carbon back into the atmosphere as CO2, but this happens very slowly over geological timescales. This long-term storage shows how carbon moving through atmosphere, ocean, land also includes the very slow geological processes. 7. Fossil fuels, ancient sunshine trapped as carbon. Millions of years ago, before dinosaurs roamed the Earth, vast swamps and oceans were teeming with plants and tiny organisms. When these died, they were sometimes buried under layers of mud and rock before they could fully decompose. Over immense periods of time, heat and pressure transformed these carbon-rich remains into coal, oil, and natural gas, what we call fossil fuels. Think of fossil fuels as concentrated, ancient sunshine and carbon stored deep within the Earth. For a long time, this carbon was mostly kept out of the active carbon cycle explained for day-to-day life. This is another example of one of Earth's long-term carbon reservoirs. Unlocking this stored carbon is a major part of the human impact on the carbon cycle for students to understand. 8. Humans join the fast lane, burning fossil fuels. For most of Earth's history, the carbon cycle was pretty balanced. But in the last couple of hundred years, humans have started to change things significantly. When we burn fossil fuels in our cars, power plants, and factories, we are taking that carbon that was stored underground for millions of years and releasing it very quickly into the atmosphere as carbon dioxide. This is like taking a slow-moving part of Earth's carbon journey for children to picture and suddenly putting it on a super-fast highway directly into the air. This rapid release is much faster than natural processes can absorb it, leading to an increase in CO2 in the atmosphere. This is the main human impact on the carbon cycle for students to learn about, as it affects our planet's climate. 9. Deforestation, losing our carbon-munching friends. Another way humans affect the carbon cycle explained is through deforestation, cutting down large areas of forests. Trees are amazing at absorbing CO2 from the atmosphere through photosynthesis. When we cut down forests, we not only lose those carbon munchers, but often the wood is burned or left to decay, releasing the carbon it stored back into the atmosphere more quickly. This means less CO2 is being taken out of the atmosphere by trees, and more might be added. Protecting and planting forests is one way we can help keep the carbon cycle explained here in better balance, supporting the natural ways carbon moving through atmosphere, ocean, land is managed. It's a critical part of understanding our role in Earth's carbon journey for children. Keeping the balance. Why the carbon cycle matters. The Carbon Cycle Explained is all about balance. For millions of years, the movement of carbon between the atmosphere, oceans, land, and living things has kept Earth's climate relatively stable and able to support life. When this delicate balance is disturbed, for instance, by adding too much CO2 to the atmosphere too quickly through burning fossil fuels and deforestation, it can lead to changes in our planet's climate, like global warming. Understanding how the carbon cycle works for kids is the first step to appreciating how interconnected everything on our planet is. It helps us see why protecting our forests, reducing our reliance on fossil fuels, and finding cleaner energy sources are so important for keeping Earth a healthy home for all its inhabitants, ensuring the future of Earth's carbon journey for children and all living things. And that's a wrap for this episode of Zentara Unlocked. We hope you enjoyed it. But the journey doesn't end here. To see the visuals that accompany this discussion, read the full article at your own pace, and discover our curated list of books for further reading, with links to easily find them, head straight over to zentara.blog. That's Zentara.blog. While you're there, explore the other 5 new articles we published today, and check out our weekly ebooks, compiling our most popular topics. Don't forget to subscribe to Zentara Unlocked so you don't miss any of our 6 daily episodes. Thanks for listening and keep that curiosity alive.